Next, we're going to try to find domain and range of functions. We're going to talk about those. We'll start with domain. Just know that domain, this is probably the thing from this unit that I get the most questions on every year. So go back through this video a couple times, maybe see if you can understand domain, because there are a few algebraic methods that we can use that'll be really helpful in finding the domain. This is really, we're just talking about mainly polynomials. And some combinations of polynomials in fractions as well. But this is an algebraic method that's going to apply mainly to our polynomials. So in order to find the domain, that is the set of all x values, all input values that work for a particular function. So for the most part, when we're talking about polynomials, we say that the domain is generally all real numbers. You've seen this, probably seen that R before with 2 bars. That means all real numbers. Now we're going to represent it in a little bit different way in pre-calc because we use interval notation. If it's everything, then we're talking negative infinity to infinity. And so I want you to write it this way rather than that R. So get used to using this kind of a notation when dealing with domain. Now most of the time with our polynomials, our domain is just going to be this. It's just going to be negative to positive infinity. It's everything, so it works out pretty nice in most cases. But what I'm about to tell you are 3 cases that I call the red flags in terms of when does the domain change a little bit. So you'll notice here, number 1, divide by 0. That is an important one. I have an example for you here, and that is y equals 1 over x. And we're going to talk about what the domain is for this one. Now you'll notice that the x is in the denominator. When the x is in the denominator, if I were to just plug 0 in for x, that would be a point at which this function is undefined. I'll put it on my graphing calculator here real quick so that you can see what this one looks like. 1 divided by x, and I'm going to use my standard zoom window. And so it looks like this, kind of a weird graph, but you might notice that in the middle we have a break. And so this 0, the x value of 0, is one that doesn't work in this function. So what we've been taught to say in the past is that, oh, domain is that x is not equal to 0. However, I want you to be using interval notation, so I want you to think of it this way. If x equals 0 is cut out of the domain, I'm going to represent my domain as a number line. If you use a number line, this can oftentimes make your life a little bit easier in terms of finding out domain. Now at 0, we just found out that 0 has a hole in it. And so everything else on my number line graph would be shaded in as far as what works. So if I see that, now I notice that I need to describe this domain in 2 chunks. One of those chunks is on the left, one is on the right. And so here's how I would describe that. On the left, it goes down to negative infinity and up to 0. Now I'm going to put rounded brackets around both of those, around the 0, because it doesn't include that. It's not an equal to bar. On the other side, we have 0 to infinity. So I can unite those two by putting a u between them, but this is going to be my domain for example 1. I want to express it in interval notation. That is my goal. On the test, you'll see interval notation. You won't see x is not equal to 0. This is the positive way to word it. This is the negative way. We're going to use the positive way. Moving along. Number 2 is negative inside a square root. The negative inside a square root, we know that that doesn't work. We talked about imaginary numbers before. If I have the square root of negative 1, that is I, because there isn't really any other way to describe it. So when we make a graph, graphs only involve real numbers, and therefore we are only going to include the ones that that make this inside either 0 or positive. So here's how we're going to find out this domain. When we've got a square root, I'm just simply going to take x plus 2 and set it greater than or equal to 0. Okay, I'm going to solve that inequality, and that'll be x is greater than or equal to negative 2. And that's what I have listed for the domain right here. Now, like I've said before, I want you to put it in interval notation, so it again might be a good idea to draw a quick number line graph. You see that that is at negative 2. It is an equal to bar, so we're going to do a closed in dot. Its x is greater than or equal to, so we'll go over here. And then we can do our left to right interval notation. So the domain that I really want you to have here is this one, that it's square bracket, negative 2 to infinity, rounded bracket. So that's each of them individually. Now there is a chance that both of these red flags are going to come up in the same problem, and I've got an example for you on that one. So here is my example. Y equals square root of x divided by x minus 5. Now, in some cases, it can be very helpful to just list the restrictions first. We talked about not stating them negatively, but sometimes it's helpful to get the problem going. So x minus 5. Since the denominator can't be 0, one thing that we can do is just say, okay, well, we know that x is not going to be allowed to be just 5. We can say x is not equal to 5. Over here, we need to make sure that this doesn't go negative, and so anything inside a square root, we're just going to set greater than or equal to 0, kind of like we did right up here. So these are the restrictions. Now, before I state this in interval notation, I'm going to put it on a number line. All right, so x is not equal to 5. That's a hole that I have. But first thing, let's just graph x is greater than or equal to 0 first. I want to start with the inequality. Now it says here we're going to use the most restrictive part of the domain, so you might be wondering which one do we use? Well, it's going to be a combination of both. So x greater than or equal to 0. I start at 0, closed in dot, and then I shade to the right. Now it also says here that we can't equal 5, so there's going to be a hole at 5. Now that I have that laid out on my number line, it's a little easier to state the domain. So my domain here goes from 0 to 5. I'm going to use the square bracket on 0, rounded bracket on 5. That's my first part. And then the second part, the right-hand side, is 5 to infinity. Remember that I'm always working left to right when I'm talking interval notation, and I can connect those with a union symbol, and there's my domain for that. So a lot of stuff with domain. Remember to make sure you're asking questions about this. This is the most frequently asked about topic from the first unit in chapter 1. So make sure you ask me questions if you have them.